x random variable here and the probability of x. We just go this times this, plus this times this, plus this times this, and so on, yes? Yeah. Add them together. Okay, so that's what this symbol states. Of course, we're well aware of sigma and what it means. Yeah, it's just sum of. So we're just going to add up the probabilities times the whatever the x random variable is. So that's what that says. We're just going to add up 1 times 0.1 plus whatever 2 times 0.3, and that's going to give us the expected value. Okay. No. Is that the same as this? Yes. Yeah. Yes. Okay. So that's expected value. Fancy name for mean. Not fancy name for mean. Another name for a mean. What is variance then? We're looking at ANCE, isn't it? Okay, I always spell it wrong. So the variance then is, well, one thing we always must remember, even if you don't know what it is yet, as the most important thing with variance, it is the standard deviation squared. Yeah, even if we don't know what it is, and I'm going to explain what it is now. Okay, so it's the standard deviation squared. That is a very crucial thing that we must remember. Now the variance has no real use. Only when you're talking about data, it's used to form data. So the standard deviation makes sense. It's how far each thing is from the mean, each variable is from the mean, how the distances of those. It looks at the distance of those, so if your standard deviation is low, that means all the things are pretty close to the mean. Whereas the standard deviation is really wide or large, that means all the data points are far from the mean or further from the mean. The variance is the square of those distances. Now, why is that useful? It's because those distances are calculated with Pythagoras' theorem or the distance formula, and they have a square root in them. And it's just easier for further statistics to deal with the variance because there's no square root on the variance. That's the reason we talk about variance and standard deviation, a shortened version. So variance is more useful in further statistics when you're calculating more things. Standard deviation is much more useful for when you're talking about data. Standard deviation actually means something to the data. If the mean is 3 and the standard deviation is 1, maybe I'll use 2, that means the data on average is 2 points away from the data on average, where the variance on average would be 1 or 5. The variance is 4. That doesn't really mean anything as such. You would have to use the standard deviation, square root the 4 to get.
Yeah, it just means the standard deviation is 2.
Okay, so we'll do an example and then maybe. So this is how do we calculate it then? So it's the sum. The variance is the sum. Oh, I've forgotten how.
Minus the mean squared times the probability?
Yep. So how far each data point is from the mean, we get by subtracting it from the mean, or subtracting the mean from it. And we square it, and we times it by the probability. So the probability. So this would be like 0.1.
What's n?
I don't see n. Oh, that's the mean. That's the mean. That's the mean.
That's mean.
Is that what you're looking at, the formula? No, that's the variance of a binomial distribution, slightly different. This is this type of discrete, a random variable.
You don't even get that.
No. So your calculator is going to do this for you. I can't remember if I ever seen you having to do this by hand, because it just takes too long. But it's on the course to do it by hand, so it could. And the standard deviation is, get this and square root the answer. So it's working out, so it's each variable, how far it is from the mean, squared, so that's the distance times by the probability, and add up all those. So if the mean of this distribution was, 2. Let's say 2, then it would be, this first one would be 2 take away 1, 2 take away 1 squared times 0.1, and then add up 2 take away 2 squared times 0.3, and so on. Yeah, you finish. That's why it's a sum of all of them. The sum of all of them. That's what the sigma means. Add them all. If you don't know what sum means. Okay, you should know that. You've surely seen that before.
I do know it.
Okay, good. All right, so the standard deviation is just all of this and then square root it. Oh, okay. The camera's in the way? Oh, okay. Okay, so let's learn how to do that by hand, and then we'll do it very quickly on the calculator. Okay, so we dealt with this example earlier on. We have these magazine sales. We have XI, and here we go with the rain.
Dude, look how dark it is outside.
I know, it's biblical. So we have the same old 23. So this is the probability of the number of magazines that were sold or whatever. If we remember yesterday, we did have the mean, didn't we? The mean was done yesterday. Does anyone have it written down so I don't have to flick back? The mean of this distribution, or expected value of this distribution, was it was 2 point something. 2.39. Okay, we'll take that. So we already worked that out yesterday. That was by multiplying this times this plus this times this and so on. We did that yesterday. Okay, so how would we get what the standard deviation and the variance is of this? Okay, so let's work it out. The standard deviation, right, what do? We get each x value, each random variable, we subtract the mean, we square it, make it positive. So x, we're going to do 1 minus 2.39 squared times 0.23. I can't read my own writing. Plus, and so on. 2 minus 3 squared times 0.38 plus 3 minus, it's always 2.39, I was getting on, 2.39 squared times 0.21. I'll remove this, it's going to be a long thing you have to type. I would never probably write this out, I'd just do it on the calculator. 4 minus 2.39 squared times 0.13 plus 5 minus 2.39 squared times 0.05. Okay, and if I did all that out,
So what are we finding? Standard deviation? Or expected value?
this will find the variance.
Variance. We already have expected value.
How do you become a calculator?
Right, so this would be a calculator question. How do I know it would be a calculator question? Because this would take too long to do by hand. So you might as well just figure out, this is how you do it formulaically. Let's find out how to do it on a calculator and get there much faster. Let's insert this into a table. So your stat list, you edit, so stat, edit, and you should have your table. I've already got it in. I've already done it, yeah. It's called, oh, you've done it too. Okay, what do we do next? We press stat again, go over to calc. One var, it's possible, someone did. One var statistics. One var stat. You want the list, you put L1 if you did this for, and the frequency L2, so this would be your second list. And you just press calculate. And you should get everything we need. So the first thing we wanted was, well, was our mean correct? And the calculator gives the mean, the x with a line over it, 2.39, fantastic. The expected value is 2.39, not the variance.
The variance is 6.97?
They just gave you the standard deviation. 1.12 is the standard deviation.